Sometimes when you get really mad, it's that's probably not good. When you get really mad, though, it's tough. I will say this. One time when I was growing up, I had this coach. He was an old school guy, and he looked at a couple of us, me being included, and we had messed up. And he goes, and me and this other kid, he knew we were like in enriched classes. He goes, you two got to be the dumbest smart kids I've ever met in my entire life.
Well, I mean, I think.
And I just think about if I ever said that today, I'd get the phone call within 10 minutes.
Oh, I would laugh if you said this to me.
Because I feel like that's not really calling someone stupid.
No, he's finding us smart.
Yeah.
But he was saying that we were the dumbest smart kid he's ever met.
My
I was
mom
like,
said that to
is
me.
that an option? Should I be happy about this? I don't know. All right, anyway, here we go. Logs. You guys remember logarithms?
Yes.
First off, today we're just going to talk about the graphs. Okay? A log graph is an inverse to an exponential. Now, of course, that's why we start with exponential graphs. We will get into all the log properties later this week. Okay? So if you graph an exponential, you have something that looks like this. A to the x. Does anyone remember what a log graph looks like from last year? You probably didn't do it as much as a normal Algebra 2 year because of COVID and the hybrid stuff. But does anyone remember what a log graph looks like? Awesome. Rachel, I know I did it with you. David?
I don't remember.
Thank you.
Wait, it's reflected over y equals x.
Correct. So it looks like this. Look familiar?
Yeah.
Yeah.
We could write log base a of x. Y equals log base a of x. David is right. Oh, y equals x. It's happening. I'm looking for everything. Are you up for it?
Yep. Just waiting for the ball. What? I have to need it. Do the rest of us. I can't do that twice.
What's that?
Do the rest of us.
What do you mean? Wait, what?
Like,
I
I
feel
would
like
like
call
call
someone
someone
or like.
Yeah. Who did I say goes and gets the nurse?
When you said
You're in charge.
Like, if we had a couple, we should have called it. I feel like there should be somebody that was just.
Fine. You go get the nurse. Emerson, you call 911, but I feel like you'll be laughing when you're calling. So I don't know if that's a good.
I can't do both. I won't.
All right, here we go.
I trust Nathan. I'm also.
Yeah, Nathan.
That's smart. I feel that.
You can reflect over y equals x. They are inverses of each other. Let's look at the properties. First off, let's look at remember the properties of a to the, we talked about it last time. So let's do a to the x. What was the domain from last time? Can anyone tell me the domain? Negative infinity to infinity. I'm looking at the exponential growth. The range was 0 to infinity, right? It passed through this point, which is 0, 1.
Is it 0?
What's that?
I'm asking the 0 is included, so I can just work it out.
PT, point. And then we had,
I said thanks, bud.
yeah, no. Then we got a horizontal asymptote of y equals 0. So this is for the exponential growth one. And we went over these on, for you guys, it would have been on Friday, correct?
Yeah.
Okay. Now, for the log graph, here's what we got. Look at that graph. Here's the log graph. What's the domain? What do you guys think? 0 to infinity. And by the way, if you want to, you have a vertical asymptote at x equals 0. It never crosses x equals 0. That's why you can't take the log of negative numbers. Did you ever know that? If you try to type that in your calculator, it won't work. Okay. How about the range of a log graph? This is log base a of x. How about the range? What do you guys think? Negative infinity to positive infinity. And this one passes through the point 1, 0. So isn't everything switched? Look at how the log graph and the exponential graph compare. Aren't they all switched? And this graph passes the horizontal line test. Let's remember, What does the horizontal line test tell us? Raise your hand if you can tell me. Sarah? Means it's 1 to 1. So what does it mean if it's 1 to 1? Giancarlo?
It's inverse from the.
Inverse exists. Yep. So let's make a note here. It is 1 to 1. So inverse exists. In this case, you have a vertical asymptote. So y equals a to the x and log base a of x, sorry, are inverses. And I always tell kids in this class, I think it's good to think about them in terms of inverses and that they solve each other, right? When we do our equations, when you have it in log form, you're going to put it in exponent form. When it's in exponent form, you're going to put it in log form. You always do the other form. They solve each other. Okay? These graphs do shift as well. Listen. I told you too. There's all those years at Moonbrook Country Club. I told you, right? My job growing up,
No.
I was a shoe shine guy.
Oh.
And I cleaned the locker rooms. The locker rooms wasn't bad. It was normal, like high school job. But the other job was me and this other guy, Jason Strauss, who, by the way, still lives in Jamestown. Nice guy. He's like on city council, which is kind of weird. Because when you know someone in high school and they end up like serving on like city council, I'm like, yeah, you used to like do drugs behind like the school at homecoming, but whatever. Okay, cool. Anyway. Wait till you see where you all end up. We had this little room, probably about the size of like Juju and Elijah's row here. Tiny room. And what we would do is the golfers would bring their shoes. Not to sound stereotypical, mostly men. Occasionally we'd get some women's shoes, but mostly men. And they would, when the men would golf, they sometimes leave us their dress shoes, like buff them up all shiny, you know, if they were like on a business meeting. But sometimes mostly it was to clean their golf shoes after they got off the course. They just put them on this little rack. They put like $1 or $2 in them. Nothing like a man's smelly shoes with a bucket in it that you got to dig out to clean it. But anyway, we cleaned them with turpentine. So I think over the years I worked at Moonbrook, probably about 5 years, high school and early college, I inhaled a good couple gallons of turpentine by just working in there. So I think I have permanent lung and brain damage from that, which I am now thinking that's why my handwriting's so bad. So kids, it's not me, it's because of my high school job. I've coughed for like 20 years. That's not good. When I was going through all my other medical stuff, they were like, yeah, your lungs look a little like, yeah. You didn't know. It's okay, I made a ton of money in high school. I know it doesn't sound much, $1 or $2. Okay.
But we'll also do 50 or 60 pairs, like.
Right, if you did 20 or 30 pairs a day, the
Yeah.
tips was just money in my pocket. It was never claimed, we just took it. We didn't make minimum wage, $5.15 an hour. I'll never forget it. That was minimum wage back then, $5.15. But then tips were under the table.
Oh, that's nice.
So that was nice. And every once in a while, one guy would walk up and be like, go like this. Oh, I got some 50 here. This is good for a while. So he'd give us like a 50, and then we'd split that, me and Jason. But then he wouldn't leave us a tip for like a month or two. But it was fine because we had a 20 or a 50 in our pocket. We were, oh, cool. That's my story for the day. So if any of you have to inhale turpentine at a job, I wouldn't do it.
Yeah.
They probably have safety procedures now. Okay, you can shift the graphs too. Just make a note, rules are the same. Okay? Now, let's say we have f of x equals log base 3 of x minus 3. Tell me how this graph shifts. Raise your hand if you can tell me how this graph shifts. This one. Giancarlo.
To the right 3.
Good, to the right 3. So what I'm going to do real quick is sketch normal log of x. A normal log graph goes through 1, 0. Okay? And again, looks like this. So this is just log, we'll say this is log base 3 of x. Technically, it should go through 3, 1 as well. So there's a couple points, 1, 0, and 3, 1. Okay, everyone okay with that? So now, oh, wait a minute, this should say x minus 3, that's weird, that's a typo, I apologize, I don't know why I did that. Okay, to the right 3. So, by the way, your vertical asymptote is x equals 0. The first thing I would do is move my asymptote. What's your new asymptote gonna be? David?
X equals 3.
Yeah, 1, 2, 3. So now my asymptote is x equals 3. I'll change colors here. And the other easiest thing to do is just move a couple points. So if you're at 1, 0, now you're gonna be at 4, 0, right? If I move it to the right 3, and if you're at this point here was 3, 1, so now you're gonna be at 6, 1. So this graph is just gonna look like this. Tell me what the domain of the graph in pink would be. Oh, always label your graphs too. That's a big like algebra 2 thing. Not as big in pre-calc, you don't draw as many graphs, but always label them. And by the way, you know what I didn't take off on your test? Remember when you had to sketch that graph on the first one? Like with the polynomials? I do get your test back to you later this week. No, you guys did put arrows on the end. Tisk. I didn't take off for it this time. MCC would make me take off on a test. If you forgot arrows on a graph. This isn't like the Regents exam where it goes to the end of the box on the, the group. Okay. Anyone do domain? Graph in pink. Think about it. Your domain is normally 0 to infinity. We've gone to the right 3. Aubrey. Good. How about the range? Raise your hand if you can tell me the range. Juju.
Negative, negative, infinity.
Good. How about the asymptote? We already did. X equals 3. I also, by the way, besides the turpentine issue, I also just have a cold that I can't get over. I think everyone has a cold right now.
And it won't go away.
And part of the issue for us is my daughter's at daycare. She's bringing that home, and here I am. All right. Determine the inverse. By the way. How do you find an inverse? What do we do? Switch x and y. Now, I'm going to write it like this. Now, we're going to get into this. So if you don't remember this totally today, that's okay. Does anyone remember how you write something from log form to exponent form? What's our saying? I don't know if Mr. Matt teaches, I don't know how he did it last year, and I wasn't even here to yell at him about it. Base number power. Does that look familiar?
Yes.
Yes, it does, Daddy. I don't remember. I feel like do a couple of them.
You were there.
You would write it in exponent form. So this is the base, this is the number, this is the power. So if I wrote this in exponent form, base, number, power, we're going to get into this. You would say 3 to the x equals y minus 3. Does that make sense? We're going to work on this more after today, so don't worry about it. But look, see, 3 to the x equals y minus 3. And then if you add it over, so you get y equals 3 to the x plus 3. That's the inverse. That's the inverse of the log one. I just added the 3 back over to make it y equals. We'll talk more about that in a minute. But does that does that look at all familiar? Okay, let's practice it more. Okay. Here's the inverse of a to the x is called the logarithmic function. This is a log function if and only if x equals a to the y. Again, if you swing it up, a to the y equals x. What I always tell kids, logs are exponents. Okay? Let me see your pack really quick. Thanks. For example, does this sound familiar? The log base 2 of 8. You guys know what that is?
No.
Sarah? It's 3. Because the answer to the log of the next one, so you have 2 to the 3rd equals 8. Here. Let me pull up a calculator. By the way, I have too many tabs open. My brain is like on overdrive right now with this. Let's take a break for a minute. Oh! I was watching my Browns news. Your hat says hello pumpkin.
Does.
Like, what's that hat for? Is it for like a store or a thing, or is it literally just like a fall hat?
Yeah, it's just fall.
Oh, that's nice. Oh, on this other note, before we get into this, are any of you in Rotary going to be at the trick or treat Halloween thing next week for the kids?
That's this Friday.
No, somebody gets.
Oh. Okay.
Next Tuesday, they do something for the staff's kids. So I'm bringing my daughter, my wife. She's a penguin. Here's the issue we have. What? David, that's inappropriate. We got her this costume. It fits. My daughter's obsessed with penguins. We go to the zoo, she's talking about penguins the whole way there. She calls penguins yayas, by the way. Because when she was first learning to talk, she was trying to say waddle. So she still refers to them as yayas. But anyway, I think she's scared of the costume. My wife tried to put it on her last night. And she like had it on for like 5 minutes and then started screaming. So we may have a situation. So we're gonna start putting it on a little bit each night. But if any of you are around next Tuesday after school, Miss Landis organized it for Rotary, and they just set up in some of the rooms, and the teachers take their kids, walk around like trick or treating. It's really nice. It's cute. That's all I got for that. Okay. Anyway, here's the saying. It's right here. Base number power. So the log base 2 of 32 equals x. Okay, you guys probably just, you remember doing this, right? Log base 2, 32. The answer is 5.
Yeah.
And what they're saying is the reason the answer is 5 is because 2 to the 5th equals 32. See, the answer for a log is an exponent. And the answer is an exponent. Is this sounding at all familiar to you people? Okay. The log of 1 base a is always 0 for any a. No matter what. Why? Because if you write it in the form base number power, a to the 0 equals 1. Okay, so the log of 1 is always 0, which is why if you plug these into a graph, this is like the point 1, 0 is always on a log graph. See how that works? The log of 1 is always 0, no matter what. Like watch. Oh, by the way, do you guys remember what's the common base?
10.
Thanks, Emerson.
You're welcome.
Doing that fast. No, it's just bad technology. See? Well,
If you just leave it blank on there.
I know, but I don't want to leave. What? Okay, we're gonna X out of this. I'll come back to it later. Anyway, go ahead. Write this one. Try to do letter A, and then. By the way, I will show you over the next few days how you do this without a graphing calculator. Who could write first off? Who could write that for me in exponential form? Right here. Okay, Sarah.
4 to the x power.
Good. 4 to the x equals 2, right? Base number power. Anyone know what x is? 4 to what power equals 2? Aubrey? Good, yeah, it's actually a half power. So you can get into, weird ones. How about letter B? Log base 3 of x equals -1. Anyone write that for me in exponent form? Maddie?
Would it be 3, the -1
Yep,
equals x,
good. So what does x equal? 1/3. So
1/3?
good, yep. And by the way, you guys know that you can't you can't take the log of 0 or negatives, right? Here's why. If you go on your calculator, I don't know why. What is wrong? Kids. Okay, so if you don't put a base in, it assumes it's 10. It will not do a negative number. Here's why. The graph treats it, understand. But let's say you did the log base 2 of -4 equals some x, right? If you did 2 to the x equals -4, is there ever an answer for that? No, no answer. So the general rule of thumb, and it's supported by the graph, is cannot take the log or natural log, we'll get into that in a minute, of 0 or negatives. Okay, you cannot take the log or natural log of 0 or negatives, which goes right back to what we said earlier. Hold on a minute. I love it when things tie together. Back here, you told me the domain, not for the shifted one, but for the regular one, was 0 to infinity, right? So your number has to be above 0 with a parenthesis. If you try to do log of 0, it won't do it. All right. Do you guys remember what an ln is?
Is that just with the base of 10?
No. Log is a base of 10. ln is with a base of e. So there's actually two ways to write it. You can write it as log base e. That's fine. Or you can write it as ln. If there's an ln, there is a little e there, you don't have to write it. Okay. So ln of x is like saying log base e of x. Okay? Same idea. If you have e to the x, looks like that. You reflect over y equals x. And you get ln of x. ln of x graph and log graph look exactly the same. Why? Because ln is a log graph. That makes sense? It's just a log with a base of e. So. Everyone good with that? Okay, hold on. Let's see what else we have. Oh yeah, there are some it says remember the properties of ln. We're gonna do more properties tomorrow. But I'll oh yeah, look kids. This right here, when we get there, we'll do it. But if you ever see one like this, ln's and e's kind of sort of like cancel each other out. Okay. The natural log of e to the x is x. So for example, if they tell you what's the natural log of e to the 5th, the answer is just 5. The reason is, if you wrote it like this, if you wrote ln as log base e of e to the 5th equals x, watch. If you swung it up, you'd have e to the x equals e to the 5, right? Base, number, power. So the only way those are true is if x equals 5. Okay. Or if you had this, e to the natural log of 7, that's just going to equal 7. So if you ever see those little identities in there, I always just kind of think e's and ln's sort of cancel each other out. But the thing I want you to remember here, when we do all our properties tomorrow, the properties of ln are exactly the same as log. So all the ln rules are the same as all the log rules. They're all exactly the same, okay? We're going to get going on those a little bit next time. Okay? Come on, let's try this one more time. Why is it? Oh! It worked. No? Okay, take 4 squared equals 16. Now watch. By the way, oh, on your little calculator, there should be an ln or e button on there. They usually are paired together. If you have the yellow one, you gotta go second PRB. Okay. Watch. If you type in ln, and then let's say you did e in parentheses to the 7th, you got to put 7. Or if you did e raised to the natural log of 7, the e's and ln's kind of distinguished. Yeah, make sure you're okay. Was everyone okay where to find the e button on there before? The ln button's probably in the same spot or around close. They're always paired together. Yeah, the problem is everyone's calculator is a little different. All right, Maddie. Everyone good? All right, I'm gonna stop. Well, here, the problems I'd like you to look at, if you get a chance for tomorrow, not much. I'm so nice to you people. I hear about how much homework you have for your other class.
Yeah.
1, 3.
You could probably just stop there.
Why don't you relax? Why don't you relax, champ? Let's do 1, 3, 4, 5, 9. I'll write them down. These shouldn't take long. Move over quickly. Give those a try, please, for tomorrow. There's only 5 questions. You can work on them now. We're done a few minutes early. I'm gonna stop. If you wanted to work on it now, you could.